Hi everyone, a warm welcome to TGIF, yet another exciting episode. In one of the past episodes, we covered multiple fine tuning techniques, and out of that, reinforcement fine tuning was one of the most exciting techniques out there, which is based on rewarding the models on top of how they behave, and then they learn from the data sets given. Now, with that in the background, we have additional capabilities when it comes to grading some of these models with respect to fine tuning. In this episode, we'll explore a few tools and techniques which will help us in better reinforcement fine tuning with our models. To join me on this short conversation, I have Nandini Muralidharan, Principal Product Manager, Azure AI Foundry. Hey Nandini, warm welcome to TJF.
Thank you so much, Divya, for having me around.
Yeah. So, I think we covered RFT in one of the previous episodes.
Yes.
What's more to RFT now?
So, reinforcement fine tuning, why did it start? Because reasoning models are becoming very, very powerful. And there is a need for all these reasoning models because we would want capabilities with less number of data. That's what we established last time.
Yep.
What we are happy to announce is we have GA'd this product with a couple of multiple graders getting added to it. An example of what we are covering today will be custom code grader or a Python code grader, wherein there is something in your mind and you would just want to codify it than letting an LLM grade the situation because maybe humans just exactly know how you would want to grade it because of years of practice. You just want to use that instead of doing roundabout calls for having a LLM as a model or a grader. And hence today's topic we'll discuss on how can you use Python code as a grading logic for your reinforcement fine tuning and how can you optimize that further.
So we are using code to grade the fine tuning technique. So how does this work? And what is the logic behind that? And how does this happen on the AI Foundry platform?
Okay, so I think very similar to what we orchestrated last time for reinforcement fine tuning or any fine tuning technique on Azure OpenAI, because our goal is to make it as simple as possible. We have a single pane sheet wherein and which we will demo very soon. You enter your code on a blob with a JSON file, or you have a Python code somewhere else, just import that Python file into it and say, okay, model, I'm giving an example, say, of 4 numbers, and I would want the target to be known. And then I insert both of it to the model saying that, okay, these are the 3 numbers, this is the answer which I want. If the answer is the same as what the model provides, give it a score of 5. If the answer is wrong, give it a score of 1. An example like this. It's very easy to code this, right? Instead of asking an LLM saying, this is the logic I would want you to use,
Got it.
etc. So you can just go ahead, code this logic, mathematical, and just put it inside it, dump it. And this can go to complex logics now. Like, for example, I want to match legal files of 19 clauses which are happening in public web space.
Okay.
And then the complexity increases. So now if you're able to apportion it very in a sizable manner, it just becomes very easy to write a code around it because the execution of this task becomes much more simpler and easier when we do this
Got
with
it.
a code instead of other graders. So all the techniques are available, but because we are a platform, we're just providing it to you so that you can pick and choose what you would want, but highly recommended and was used by our private preview customers.
Okay.
So just happy to share it that it's GA now for folks to use it.
Wonderful. So I think it's a systematic way to grade models in that sense.
Correct. You're right.
Got it. So can we have a quick demo on this, Nandini?
Let's get started. This is ai.azure.com. So the moment you hit that in the browser, AI Foundry will open up. Like we saw last time, this is the fine tuning tab. I go to a fine tuning tab and then just go ahead and start fine tuning the models, whatever I would want. So here is where I go, say fine tune. I pick for whatever models I need. O4 mini is what we have GA'd with reinforcement fine tuning technique, which is what we saw last time, right?
Yep.
You select the model here. This is O4 mini here. I go ahead and add my training data set, what I would want, and also can just add the sample data sets as well, depending on how the customer is placed. Reinforcement fine tuning technique, validation data is mandatory because that's where it learns from and reasons better. So I have the validation data, which is added out again. And then you just go ahead and add your suffix. And I'm just going to say demo for the suffix. Reasoning effort, this is the logic where it helps you control how much you would want to reason. You want to take longer time. This is the box where we add grader schema.
Okay.
So the Python code grader. So here I'm just pasting out the Python I would want to run. This is just a sample JSON file. There are multiple samples placed out as part of our documentation piece here, where I have given you the custom code creator, and we also have sample examples of saying the same number logic example. It is placed out here as part of the custom code creator. So if you see here, this is the JSON file of the number code creator. You can just go ahead and start it and start the run. And this is just a test file, so I'm just using this. So let's go here. We add out what we would want as response formats, leave the config as usual, and then just go ahead and submit it. Let me take you to a job which we have already run and see what happens. It's in a very similar data set. Is what we've added. This is how you will see the greater is Python, which is used. I did not impose any reference format. And to do this kind of file, it took about 1 hour to reason it. The advantage of reinforcement fine-tuning again remains that you can start with as simple as 20 examples and start making a dent on the model in terms of post-training techniques. And knowing that the advancements of models, pre-training, we know is a lot of deep science complexity. RL trainings, though they are in an advanced version of post-training techniques, but they are still much more doable as compared to pre-training the model completely. And hence all of these are exposed so that you can bring in all the data which your proprietary company has and feed it into the model for your particular use case and make a dent on that model.
So I think we are getting closer to model customization and much more easier done on the Azure platform. By the way, this feature is GA. It's available for O4 Mini on the Azure AI platform. The custom Python coder is also available for you to try it out. And reach out to us if there is any question. We will also share the blog link post for you to get more examples and so that you can try that on the Azure platform. So until then, signing off. Bye bye.
Bye bye. Thank you, folks. Happy fine tuning.